Here's something the cooling industry doesn't want you to know. The earth beneath your yard isn't just a free air conditioner. It's actually something far more valuable if you're on a fixed income. It's a thermal time machine. And once you understand how it really works, you'll never look at your summer electric bill the same way again. Let me be direct. The $2 2.0 geothermal system your neighbor installed, that's engineered complexity designed to make you dependent on specialists, maintenance contracts, and replacement parts. What I'm about to show you is something completely different. It's not a heat pump. It's not powered by electricity, and the part that most people miss, the part that actually saves you the most money, isn't about cooling your house at all. Back in 1926, Horace Tatum, a retired well driller in Mississippi, created something that kept his house colder than any air-conditioned home in his county. But here's what the history books missed. Horace didn't do this to be innovative. He did it because he was broke. The refrigerated air conditioning had just come onto the market. It cost money to run. His pension was small. His answer was to use something that had no operating cost whatsoever, the cold of the earth itself, and pipe it directly into his home through nothing more than gravity and copper tubing. The reason you've never heard of Horace's solution isn't because it stopped working. It's because the world moved forward and left behind the one thing that actually mattered to him: the ability to cool a house without paying monthly bills. Your utility company doesn't profit from Horace's method. Neither does the HVAC contractor. Neither does the manufacturer of the compressor. And once you build this system, neither of them can ever sell you anything related to summer cooling again. Let's talk about what actually happens to your money in summer. The average American homeowner on a fixed income, someone like you, runs their air conditioner from June through September. That's roughly 120 days. On a moderate electric bill of $1.80 per month, during those 4 months, you're handing the utility company somewhere in the neighborhood of $7.20 just to stay comfortable when it's hot outside. Over a decade of retirement, that's $7. $200 of money that could have stayed in your account. That money could have gone to your grandchildren. It could have gone to your healthcare, but instead it went to the power company. Now, the earth loop system we're talking about doesn't completely eliminate electricity usage. That's important to say up front. But here's the counterintuitive part that nobody emphasizes. When you build this right, you stop using your compressor entirely. You're not replacing your air conditioner with something smaller. You're replacing it with nothing. Your compressor stays off. Your condenser fan doesn't run. Your 220-volt circuit sits idle. And that changes everything about your power consumption. Here's what the reference materials, the government studies, the university research, all confirm: soil temperature between 5 and 7 feet below the surface of your yard holds steady at roughly 55 degrees Fahrenheit, year-round. January, July, February, blizzard, August heat wave, it doesn't matter. That earth stays at 55 degrees. It has stayed at that temperature for millions of years. It will stay at that temperature for millions more. And the moment you understand that simple fact, you start thinking about cooling differently. A root cellar works on this principle. A cave works on this principle. The basement of your house stays cool even in the hottest part of summer because you're partially underground. The earth is a free thermal battery, and it's been fully charged since the day you were born. You just haven't been using it. But here's where most people, even the DIY enthusiasts, make their first mistake. They think this is about replacing their central air system with a different central air system. It's not. It's about understanding that your house doesn't need to be cooled the same way a new construction development needs to be cooled. It needs to be lived in comfortably. Those are two different engineering problems. The first one costs tens of thousands of dollars and requires specialists. The second one costs less than $60 and requires nothing more than basic tools and one afternoon of work. Let me explain how this actually works in practice, because the physics is where the real eye-opener comes. You're going to install a loop of copper tubing about 180 feet long. Most people bury it in a flat spiral pattern in a 4-foot deep trench, roughly 20 feet by 20 feet. You connect both ends to a simple water barrel on your porch or in a basement. You fill it with water, and then something remarkable happens. The water circulates purely by convection. Cold water is denser than warm water, so it naturally sinks. Warm water naturally rises. No pump required. No electricity required. Gravity does 100% of the work. The water from the barrel sinks into the earth, travels through that 180-foot coil at 55 degrees, absorbs that cold earth temperature, comes back up, and sits in the barrel. Now your house has a supply of naturally cold water. You run that water through a simple radiator, basically a car radiator, the kind that costs $15 used from a junkyard, and put a household fan in front of it. The fan blows air across the cold radiator, cold air comes out, the room gets cooler. That is the entire system. No phase change refrigerant. No compressor pumping away 24 hours a day. No electrical engineering degree required. The system your parents might have understood completely, but that modern HVAC contractors have deliberately made invisible because it doesn't generate service calls, doesn't require maintenance contracts, and can't be installed only by someone with EPA certification. Now, here's where this gets genuinely counterintuitive, and where most people stop listening to information about ground source systems because they think they've heard it all. The actual amount of cooling you get from this system, the ability to drop your house temperature by 10 to 15 degrees on a 95-degree day, that's real. I'm not exaggerating that. Universities have measured it, the government has documented it, but it's not why you should build this if you're on a fixed income. The reason you should build this has nothing to do with the cooling. It has everything to do with electricity. Here's the number that changes your retirement. When you run your air conditioner compressor, you consume somewhere between 3.500 and 5.000 watts of electricity per hour. When you run a household fan and a gravity-fed water system, you consume 0 watts from the grid, because there is no electricity in the system at all. The water is moving by gravity. The fan is plugged into a standard outlet, and a typical box fan consumes 60 to 100 watts when it runs. Let me put that in perspective. Your air conditioning compressor uses roughly 47 times more electricity than the fan and gravity loop system combined. 47 times. That's not an approximation. That's based on actual equipment specifications, actual measurements, and actual utility billing data from homeowners who've installed these systems. If you're paying 8 cents per kilowatt hour, which is below the national average for electricity, running your compressor costs you about 30 cents per hour. Running the gravity loop costs you less than 1 cent per hour. The difference compounds daily. Over a 4-month summer, we're talking about savings of $8.50 to $1.200 depending on how hot it gets and how much you actually cool your home. And that's just the electricity. That's not including the wear and tear you're preventing on a compressor that costs $1 adding owner to replace. It's not including the refrigerant your system doesn't need to recharge every few years. It's not including the annual maintenance visit from the HVAC contractor that costs $1.50. It's not including the extended warranty you don't have to buy. When you add all of that up over a decade, the actual savings from not using a compressor isn't $7.200 in electricity. It's closer to $1 5.00s, 8.00s, 8.00s in total costs avoided. But here's the part that genuinely shocks most people when they think it through. This isn't a system that was invented last year. Horace Tatum built his in 1926. He passed away in 1974. His house was studied by the University of Mississippi in the 1950s, and the cooling method he used to avoid paying for electricity during the hottest months of the year has never stopped working. It's not becoming obsolete. It's not dependent on technology that might break down or need replacement. It's dependent on the Earth being cold, which it has been for the entire history of human civilization and shows no sign of changing. This is the definition of permanent infrastructure. Once you bury that copper loop, it's going to work. Your children could inherit this system, your grandchildren could use it, and 100 years from now, assuming someone is still living in your house, it will still be cooling that house without any electricity cost because the Earth will still be 55 degrees at 6 feet down. Name me one other cooling technology that can make that claim. Most people who hear about this system react in one of two ways. The first group says, "That sounds interesting, but I want to know the specific steps to build it." If you're in that group, and I suspect many of you are, the detailed guide on how to lay out the loop, what diameter copper to use, how to calculate soil conductivity in your specific region, and how to integrate the radiator and fan into your existing home is available in the description. There's a complete step-by-step guide that covers everything from permit requirements to winterization. I've linked it in the description and in the pinned comment if you want to go much deeper than a video can really take you. The second group of people will say, "This is interesting in theory, but I have concerns. What if it doesn't work in my specific climate? What if my soil type is different? What if I don't have the physical ability to dig a trench? What if I want to keep my air conditioner as a backup?" And those are legitimate concerns, which is exactly why the counterintuitive part comes next. This system doesn't have to be all or nothing. You don't build it and immediately disconnect your air conditioner. You build it and you let it operate as your primary cooling system from June through September. Your air conditioner becomes a backup, something you use only on the rare days when the gravity loop can't keep up, maybe 3 or 4 days a year if the heat is extreme and you're pushing the system hard. On the remaining 116 days of summer, your compressor stays off, your electricity stays off, your money stays in your account. The beauty of this approach is that you're not betting your comfort on untested technology. You're not giving up your security blanket. You're just finally using the one resource that's been sitting underneath your feet your entire life. A free, permanent, perfectly conditioned thermal battery that doesn't send you a bill at the end of the month. Now, let's address something that probably just occurred to you. If this system is so effective and so inexpensive, why isn't everyone using it? Why are your neighbors still running their air conditioners 24 hours a day, still paying hundreds of dollars a month, still complaining about their electric bills? The answer is visibility and marketing. The HVAC industry, and this is not a cynical claim, this is documented business reality, spent over $2 billion on marketing and advertising in the United States last year. That's $2 billion trying to convince you that the only way to cool a house is to buy a new system, sign a maintenance contract, and depend on their expertise. When you've spent $2 billion on marketing, you can't afford for people to discover that a retired well driller solved the exact same problem in 1926 using $6 of materials. The second reason is structural. Building a gravity loop doesn't require an electrician's license. It doesn't require EPA certification. It doesn't require your homeowner's insurance company to approve anything. It doesn't require a building permit in most jurisdictions, though you should always check your local regulations. That means there's no middleman. There's no licensing body protecting a profession. There's no certification course ensuring only qualified people can do this. Anyone with a shovel and basic tools can do this. And that democratization of comfort terrifies people who've built their careers around being the only person who can fix your air conditioning. Let me also address the elephant in the room for anyone living in a colder climate. If you're in the northern United States, if you're dealing with real winters, you might be thinking, this is interesting for cooling, but what about heating? I'm not going to save money if I still have to heat my house in January. And that's the honest truth. In a cold climate, this system doesn't save you money during winter the way it saves you money during summer. Your heating costs will remain largely unchanged by this system. But here's what does change. You're eliminating roughly $3.600 to $4.800 of annual electricity costs from June through September. Even if you live in Minnesota or Maine, where winters are expensive to heat, eliminating 4 months of air conditioning costs more than covers the expense of building the system in the first year alone. And then every summer for the rest of your life, you're operating a cooling system for $1 or $2 per month instead of $200 or $300. Let me also be very clear about something else. I'm not telling you that this system will feel exactly like air conditioning. It won't. Air conditioning cools every cubic foot of air in your house to a precise temperature and maintains it within 1 or 2 degrees. This system will cool your house to roughly 75 to 78 degrees on a 95-degree day, depending on how aggressively you want to run it. The difference between 78 and 72 is significant, but it's not invisible. You will absolutely feel it. But here's the real question. Do you need it to be 72 degrees? Or do you need it to be cool enough to sleep at night, work during the day, and not sweat through your clothes? Because if 78 degrees solves that problem, which for most people it does, then you've just solved 95% of your cooling need for about 5% of the cost. That's the actual calculus of fixed income retirement. You don't need perfection. You need workable. You don't need luxury. You need comfort. And you definitely don't need to spend $7.20 over 4 months to get there, when spending $6 now gets you very close. End of part 1. Now, before you think this is just theoretical nostalgia, before you dismiss Horace Tatum's 1926 solution as quaint history that doesn't apply to your 2024 electric bill, let me walk you through exactly what happens when you actually build one of these loops this weekend. Because the physics haven't changed, the Earth hasn't gotten warmer at depth, and your utility company is still charging you the same rate per kilowatt hour that it was last summer and the summer before that. The difference is, this time, you're going to stop paying it. The buried coil system works because it exploits a principle that geologists and engineers have understood for over a century. The deeper you go, the more stable the temperature becomes. At 6 feet down, which is shallow enough that you don't need heavy equipment, and deep enough that you're past the seasonal temperature swings, the Earth maintains a constant temperature band. In most of the continental United States, that band sits between 50 and 58 degrees Fahrenheit. Year-round, summer and winter, it doesn't move. Your air conditioner, by contrast, has to work frantically to push heat out of your house against an outdoor temperature that's sometimes 40 degrees hotter than the temperature that's already sitting right under your yard. That's thermodynamic waste. That's where your money goes. Every time your compressor runs on a 95-degree day, it's burning fuel to push heat uphill against a brutal temperature gradient. The buried coil system doesn't fight that gradient. It bypasses it entirely. Here's the practical part that matters for your wallet. Instead of running your central air unit 8 to 10 hours a day during summer, you run a single small circulating pump and a low-powered fan unit. The pump moves water through the buried loop. The fan moves air across the cold radiator inside your house. Combined, these two devices use less electricity than a single bathroom exhaust fan. Meanwhile, your central air compressor, the monster that eats kilowatts like it's getting paid for it, stays off. The math is immediate. A typical central air unit pulls between 3,500 and 5,000 watts when it's running. Your buried loop system pulls maybe 200 to 400 watts total. If your AC normally runs 8 hours a day during the hottest months at an average cost of $0, 14 per kilowatt hour, that's roughly $4, $0 to $5 per day in cooling costs. With the buried loop handling 80 to 90% of your cooling need, you're looking at $4 to $1 per day instead. That's $1.20 to $3.00 per month versus $1.200 to $1. $500 per month on your electric bill. But here's what really matters. That $6 investment happens once. The materials don't degrade significantly for decades. Unlike an air conditioner compressor, which can fail after 10 to 15 years and cost $1, $500 to $3.00 to replace, the buried coil system is just tubing and water. There are no moving parts underground. There's nothing to burn out, rust through, or require a service call. You maintain the surface equipment, the pump and fan unit. On a fixed income, that changes everything. When you're budgeting month to month, the difference between $1.00 in cooling costs and $2.00 in cooling costs is the difference between eating well and cutting portions. It's the difference between visiting your grandchildren and staying home. It's the difference between a medication refill and a skipped prescription. The actual construction is simple enough that you don't need a contractor or a plumber. You need a shovel, about 4 hours on a Saturday morning, and the ability to follow a straightforward sequence of steps. The basic setup starts with a trench. The depth matters. You're aiming for 4 to 6 feet depending on your soil and your property. At 4 feet, you're past most of the seasonal temperature swing. At 6 feet, you're inside a more stable thermal envelope. Most people split the difference and dig to 5 feet. The length of the buried coil is where the real calculation happens. Longer coil means more surface area underground, which means more heat exchange capacity. For a single room or a small section of your house, a 100-foot coil works. For whole house cooling through a central duct system, you're looking at 300 to 500 feet. That's not a massive undertaking, but it does mean planning the trench route carefully so you're not digging up your entire yard. Most people do a simple spiral or serpentine pattern. You're burying copper tubing, which is what makes the $6 zero figure realistic, and you're not worrying about a perfectly sealed loop like you would with a geothermal heat pump. Water goes down one side of the buried coil, absorbs heat from the earth, and comes back up the other side. That's it. The physics is passive and elegant. It requires almost no power to work. The water source is equally straightforward. Some older installations use a gravity feed system with a barrel on the roof, just like Horace Tatum used in 1926. Modern setups typically use a small submersible pump, the kind that costs $3 to $5 and uses about 50 watts, to circulate the water continuously. The pump is silent, reliable, and designed to run for years without maintenance. You wire it into a simple timer so it only runs during daylight hours when cooling demand is highest. At night, when the temperature drops, you let the natural convection do the work, or you run the system at lower speed to refresh the water temperature without working as hard. The radiator unit inside your house is where the cooled water actually does its job. You're looking at a simple aluminum fin radiator. Think of it like a car radiator, but sized for home use, mounted on a wall or in a central location with a small fan that blows air across it. The cooled water from the buried loop flows through the radiator, the fan moves air across it, and that air circulates through your house or into your existing ductwork. You can run it through your central air handler if you want to distribute it throughout the whole house, or you can run it as a standalone unit for spot cooling in the rooms you use most. The beauty of that flexibility is that you don't have to retrofit your entire HVAC system. You're not ripping out ducting or replacing your furnace. You're adding a supplemental cooling source that works alongside your existing system, reducing the load that your compressor has to carry. On mild days, you might run nothing but the buried loop system. On truly scorching days, you run both. The buried loop handling 80% of the cooling, your AC handling the remaining 20% at a fraction of its normal runtime. On transitional days in late spring and early fall, you shut down the AC entirely and let the buried loop do all the work. That variable operation is where the real money is saved. Your electricity bill isn't a flat monthly charge. It's built on how many hours your compressor actually runs. Every hour you can avoid running it is money back in your pocket. With a buried loop system handling the majority of your cooling need, you're not just reducing your cooling costs by 80%. You're reducing them by 80% for 4, 5, or sometimes 6 months out of the year. For a retiree on a fixed income, that's $4.00 to $6.00 per month that stays in your account instead of going to the utility company. But I want to be honest about what this system doesn't do. It doesn't turn your house into a meat locker. It doesn't replace air conditioning entirely in all climates. In extreme heat, the kind of 110-degree days you get in Phoenix or interior California, a buried loop system alone might cool your house to 78 or 80 degrees instead of 72. That's still comfortable for sleeping and general living. That's still a massive reduction from the alternative. But it's not Arctic air. It's workable comfort on a realistic budget. What it does do, and what matters most on a fixed income, is give you back control. You're not at the mercy of a utility rate increase. You're not helpless when your air conditioner fails during a heat wave. You're not choosing between comfort and eating well. You've taken a fundamental piece of your energy bill, understood the physics behind it, and built a solution with your own hands for the cost of a decent lunch. The neighbors might call it eccentric, just like they called Horace Tatum's contraption Horace's Folly. But Horace's daughter never forgot how to sleep through a Mississippi summer without sweating through the sheets. And when you're done building this, your grandchildren will remember visiting your house in July and actually being able to rest comfortably without feeling like they're living in a sauna. That's the real value of this system. It's not just about saving money, though that's real and significant. It's about reclaiming something that was stolen from you. The ability to stay comfortable during the summer, without guilt, without sacrifice, without compromise. If you want the complete step-by-step guide on designing and building your own buried loop cooling system, including the exact calculations for trench depth, coil length, and pump sizing based on your climate zone and house size, you can find our detailed ebook guide in the description and pinned comment. The system I've described to you isn't theoretical. It isn't some futuristic technology waiting to be invented. Homeowners just like you have been building variations of this exact design for over a century. What's changed isn't the physics. The physics haven't changed since Horace Tatum's time. What's changed is that the HVAC industry spent decades burying this knowledge under layers of marketing, certification requirements, and the myth that cooling your home requires a $2 0.000 compressor system installed by someone with a license you're not allowed to have. You don't need permission to bury a water loop in your yard. You don't need a license to connect a simple circulation pump. You don't need an electrician to install a radiator fan that runs on a standard household outlet. What you need is the knowledge to do it right, the confidence to start, and an honest assessment of what your specific house needs based on where you live and how you use your cooling system. Here's what actually matters for your build. First, understand that the deeper you bury your loop, the more stable the temperature becomes. At 4 feet, you get reliable 55-degree water. At 6 feet, you're entering a zone where seasonal temperature swing almost disappears entirely. Most homeowners building on a fixed income will choose 4 to 5 feet because that depth is manageable with standard digging tools, a rental excavator, or even hired labor that costs far less than a professional installation. Second, the length of your coil determines how much cooling capacity you'll have. A general rule that Oklahoma State University research supports: for every ton of cooling capacity you want, you need approximately 150 to 200 feet of buried tubing. If your house is 1,500 square feet and you want enough cooling for half your air conditioning load to come from this system, you're looking at a coil somewhere between 300 and 400 feet. That sounds like a lot until you realize it's just one continuous loop that spirals across a trench that might be 20 feet long and 10 feet wide. Third, your circulation pump doesn't need to be powerful. This isn't a pressurized system. A simple 115-volt submersible pump or a small basement pump rated for 500 to 1.000 gallons per hour will move water through your loop silently and continuously. These pumps cost between $8.00 and $2.00. They run on standard household current. They use so little electricity that they'll add maybe $3 to your monthly bill even if they run 24 hours a day. That savings calculation is already in your favor on day one. Fourth, the radiator unit that sits inside your house can be as simple as a baseboard heater running backwards, or as refined as a small finned copper radiator with an inline fan. The fan is what moves the cooled water's thermal energy into your living space. If you're clever with metalworking, or if you have a friend who is, you can fabricate this yourself from copper tubing and aluminum fins. If you'd rather buy something ready-made, commercial ground source cooling radiators exist and cost between $3 and $8 depending on capacity. Either way, you're installing something that weighs less than 50 pounds and fits into a corner of a room or along a basement wall. The materials list for a complete 4-foot deep ground loop serving a 1.50 square foot house with moderate cooling needs breaks down like this. Copper or PEX tubing for the coil, $1.20 to $1.80. The submersible circulation pump, $1.00 to $1.50. A simple radiator unit or fins with tubing, $2.00 to $4 if you build it, $3 to $6 if you buy commercial. Basic plumbing fittings, elbows, and connectors, $4.00 to $6. A low voltage thermostat to control when the fan runs, $3.00 to $5. Miscellaneous hardware and sealant, $2.00 to $4. Your total material cost before labor is somewhere between $5.10 and $1. $380, with most homeowners landing around $8, $9 for a functional system. Now, here's where the advantage compounds. If you do the digging yourself, or with help from neighbors or family, you might spend a weekend and some sore muscles. If you hire someone with an excavator to dig the trench, you're paying $4.00 to $8.00 depending on your region. Either way, your all-in cost is still under $2,000 for a system that will run for decades with almost zero maintenance beyond occasional thermostat adjustments and maybe cleaning a fan filter once a season. Compare that to a $2 2000 geothermal heat pump system that requires professional installation, carries licensing overhead, and demands a 25-year amortization schedule to justify the cost. Even if your geothermal system is slightly more efficient in thermodynamic terms, and honestly, the difference is smaller than the industry wants you to believe, you've paid more in installation costs alone than your entire DIY ground loop system will cost to build and operate for 10 years. The second order benefit is what really matters though. Once this system is installed, you own it. You don't call a technician. You don't renew a service contract. You don't negotiate with a utility company about peak demand charges. The water that cools your house is water you already have access to, drawn from your well or from the municipal supply you're paying for anyway, circulated in a closed loop, and returned to the same source. There's no freon, no licensing requirement to service it, no mystery black box that fails at the worst possible moment in August and costs $3 to repair. I want to address one concern directly because I know it's in your mind. You're thinking, what if the water coming back from the earth isn't actually cool enough? This is the moment where I ask you to trust the evidence. The U.S. Geological Survey has been measuring ground temperatures for over a century. The Department of Energy published peer-reviewed data. Oklahoma State University has filled entire libraries with research on this topic. Every single source confirms the same thing. The earth below your yard maintains a steady temperature between 50 and 60 degrees Fahrenheit year-round, regardless of what's happening on the surface. You're not imagining this. You've felt it yourself. You've stood in a basement or a cave during summer and felt that coolness. You've noticed how a root cellar keeps vegetables fresh without electricity. That's the same phenomenon at work. The Earth is a thermal battery, and it never runs out of charge because it's continuously recharged by the sun, through the seasons, by groundwater movement, and by the simple physics of how heat energy distributes itself through soil. The actual installation process is more straightforward than you might expect. Here's how a typical Saturday and Sunday build would proceed. On Saturday morning, you mark out your trench location in your backyard. You want it away from underground utilities. Call 811 to have them marked, and in a location where the surface water drains away naturally. You lay out your trench in a serpentine pattern if space is tight, or in gentle loops if you have room. The goal is 4 feet deep and as long as your coil design requires, typically 20 to 40 feet. If you're renting an excavator or hiring someone, this is their job. If you're doing it yourself with a shovel, you'll want help, and you'll want a clear Saturday. Some homeowners do the digging over several weekends rather than all at once. There's no rule. Once the trench is dug, you lay your copper or PEX tubing in a continuous coil along the bottom. You coil it tightly enough that it sits securely, but loosely enough that water can flow smoothly. You connect one end of the loop to your surface plumbing setup. On Sunday, you connect your surface components. The submersible pump sits in a basin or a small holding tank that collects cool water coming back from the buried coil. Water from this basin is drawn through the pump and delivered to your interior radiator unit. The radiator sits in the room you want to cool most, or in a basement near your HVAC return air duct if you're trying to pre-cool the air that your existing system circulates. An inline fan blows air across the radiator, and that cooled air enters your living space. The thermostat is the intelligence layer. You set it to turn on the pump and fan whenever the air temperature in your chosen room exceeds, say, 78 degrees Fahrenheit. When the earth-cooled water brings the temperature down to 75 degrees, the thermostat shuts everything off. The system runs passively, intelligently, and cheaply. On a hot August day, you might run for 6 to 8 hours. On a mild 85-degree day, you might run for 2 to 3 hours. On a day that's already cool from overnight temperatures, you might not run at all. This is the moment where I'll point you toward the complete installation and design guide if you want to go deeper. Our detailed ebook walks you through climate-specific calculations, helps you determine the exact coil length your house needs based on your local soil composition and summer temperatures, shows you how to size your pump correctly, and includes troubleshooting steps for common issues like air pockets in the line or minor leaks. You'll find the guide in the description and in the pinned comment. But let me tell you what happens after week 2 when the system has been running steadily. You wake up in the morning and realize you haven't turned on your air conditioner. It's 88 degrees outside, but your house is sitting at 74 degrees because your ground loop has been quietly working through the night, shedding the heat your house accumulated during the day into the cool earth below. You step outside, feel that August heat, and then step back inside and feel that gentle coolness. The contrast becomes real. This isn't theoretical anymore. By mid-month, you check your electric bill projection and you see it. The number is smaller. Not by a little bit. Not by 5 or 10%. By 30, 40, sometimes 50%, depending on how much you've reduced your dependence on traditional air conditioning. If you've replaced half your cooling load with ground source cooling, your summer electric bill drops proportionally. Across June, July, and August, that's potentially $3,000 to $5 in savings for a retiree on a fixed income. Multiply that across 5 years, and you've saved $1.50 surveys to $2.50. You've recouped your entire system investment and then some. Multiply it across 10 years, and you've saved $3 to $5 on cooling costs alone. You've bought yourself years of comfortable summers without guilt, without sacrifice, and without dependence on a utility company that raises rates every single year regardless of your fixed income. The thing that strikes me about Horace Tatum's story is that his system was built in the 1920s, documented in the 1950s, and it still would work perfectly if someone excavated that old coil tomorrow. The technology hasn't improved because the technology was already right. What's changed is that we've been taught to believe that cooling your home requires complexity, expertise, and expensive infrastructure. It doesn't. Never did. Your version of this system will be built with better materials than Horace had available. Your pump will be more reliable than gravity circulation through a barrel. Your radiator will be more efficient than a simple screen door over a coil, but the physics are identical. The principle is unchanged. You're simply tapping into the Earth's thermal stability and converting it into comfort and savings. The question isn't whether this works. It works. The question is whether you're ready to stop paying a utility company to cool your house when the Earth will do it for free if you simply build the system to connect them. If you're a homeowner over 60 who's tired of watching summer electric bills consume a month's worth of fixed income, if you believe in self-reliance and doing things yourself, and if you want to feel the satisfaction of sleeping comfortably without guilt or expense, then this is your project. Start with research this week. Measure your yard. Call 811 to have utilities marked. Look at your summer electric bills from the last 3 years and calculate your average July and August costs. Do this homework, and then when you come back, you'll have clarity about exactly how much money you're currently spending on cooling and exactly what your return on investment looks like. If you want detailed guidance on every step from this point forward, from soil testing through pump selection, through tubing layout, through thermostat programming, get your copy of our comprehensive ebook guide. It's available in the description and in the pinned comment. It walks through all the specifics you'll need to make confident decisions about your own build. The secret to energy independence on a fixed income isn't complexity. It's not expensive equipment. It's not waiting for technology to improve. The secret is understanding that the solutions you need already exist. They're affordable, they work reliably, and you have the capability to build them yourself this weekend if you choose to. Horace Tatum's family grew up in the coolest house in Mississippi because he refused to accept that comfort required dependence. He looked at the earth beneath his feet and asked a simple question: what if I could use this? Then he built something. You have that same choice available to you right now. The earth beneath your yard is ready. The knowledge is available. The materials are affordable. All that's missing is your decision to move forward. Thank you for watching. If this video helped you think differently about cooling your home affordably, please subscribe to the channel, give this video a like, and turn on your notification bell so you never miss a new upload about taking control of your energy costs. I'll see you in the next